Algebra 2, Chapter 3, Day 2, Classifying Linear Systems. Learning target. I will be able to classify systems of equations and solve systems by substitution. So depending on the solutions you may have for linear system equations, we can categorize the linear system equations as follows: exactly one solutions, infinitely many solutions, or no solutions. When it is exactly one solution, we call the systems consistent and independent. The graphs are intersecting lines with different slopes. So what would be an example of two linear system equations that has exactly one solution? So for example, if I have y equal x, and then another line I have y equals negative x. So these two lines intersect exactly at one point, and we call this type of system consistent independent. So again, if they have exactly one solution, then we consider this type of equations are consistent independent. Next, we have infinitely many solutions, and we categorize it as consistent dependent. The graphs are coinciding. They are the same line, same slope, and same y-intercept. So what will be considered the same line? Basically, if I have y equal x plus 1, and then the second one is exactly, so let me mark it with a different color. It is exactly y equal x plus 1. And can you tell the difference between the two? Not necessary, because they are exactly the same line. They are laying on top of each other. You are writing the same equation twice. You are graphing the same equation on top of each other. So that's the reason why it says the graphs are coinciding. They are the same line, exactly same line. So for this one, I have y equals x plus 1. So no matter you are whether trying to distinguish the black or the red one, they are exactly the same line, y equal x plus 1. They are exactly the same line. Same slope, same y-intercept, same information for both of them. And that brings us to the very last one, no solution. We categorize this type of equation as inconsistent. No solution means inconsistent. The graphs are parallel lines. They have the same slope but different y-intercept. Same slope, different y-intercept. We discussed this in chapter 2 as well. When two lines are parallel from each other, they never intersect. So what would be an example? So how about let's graph y equals x plus 1. Y equal x plus 1. And another one I'm going to graph with red color again. Say like y equals x minus 4. So these two lines have the same slope, 1, but they have different y-intercept point. One is, the black one has a y-intercept point of 1, the red one has a y-intercept of negative 4. So same slope, different y-intercept. These two lines will never intersect with each other. The system is considered inconsistent because they have no solution at all. So this is the information about categorizing the system of equation depending on how many solutions they have. Next, classify each system, consistent or inconsistent, and determine the number of solutions. So number 1, I'm given linear system equations. I'm going to use the substitution method. X plus y equals 5. I'm going to subtract x to both sides. So I have y equals negative x plus 5. Is it going to be consistent or inconsistent? So let's plug this in. Y equals negative x plus 5 into the second equation. So whenever I see the y, I'm going to replace. So let me write this in different colors so that you see exactly what I'm doing here. So I see the y from the second equation. Now I am going to replace y with negative x plus 5. So see what I'm doing here? I'm simply replacing the y with negative x plus 5. And then what do? So originally it was a 2 variable. After I substitute the y, I have turned the 2 variables into just one variable, x. So now we have 4x minus x, which is 3x, plus 5 equals 5. So I'm going to subtract 5 to both sides. We have 3x equals 0. So my x equals 0, which means my y equals 0 plus 5, which is 5. So we only have one solution. So what do we call when there's only one solution? Exactly one solution. So this system is consistent and independent. Consistent and independent. Number 2. X plus y equals 5. 4x plus 4y equals 20. So what if I multiply this equation, this very first equation, by 4? What do I get? So 4 times x, I have 4x, plus 4 times y, I have 4y, equals 5 times x, 5 times 4 equals 20. Is it exactly the same as the second one? So do they look exactly the same to you? After I multiply the first equation by 4, I get the exact same equation. So basically, are they exactly the same thing? Yes, I'm graphing the same solution, same line at all, same line after all. So what do we call this type of equation? It's going to be infinitely many solutions. So the system is consistent and dependent because they are exactly the same thing. So from this example, you may see that it's actually the same line, but they may look different at the beginning. So it's look like it's disguising itself. It's trying to deceive you. It's trying to, make something different. But in fact, they are exactly the same. If you multiply a number, get to the other equation, then they are basically the same thing. So we call equations like number 2 consistent and dependent. So the system for number 2 is consistent and dependent. How about number 3? X plus y equals 5, x plus y equals 8. So if I rewrite this equation into slope-intercept form, so first equation I subtract x to both sides. I have y equals negative x plus 5. Second equation I do the same thing, y equals negative x plus 8. So do you see that they have the same slope, negative 1, but their y-intercept point is different. One is 5, the other is 8. So what do we call this type of equation? Same slope, different y-intercept. They are parallel lines. So the system is considered inconsistent. Number 4, solve using substitutions. So let's give it a try. First equation, you are given x equals y plus 2. So that means when I see the x, I'm going to replace it with y plus 2 and put it into the second equation. Whenever I see the x, I'm going to replace it with y plus 2. So the second equation, I see x, so I'm going to rewrite it as y plus 2. And then I'm given x plus y. So I'm simply replacing this x with the y plus 2. And then the y stays as y equals 8. So y plus y, we have 2y plus 2 equals 8. As I subtract 2 to both sides, we have 2y equals 6. So my y is going to be 3. And that means as I plug it back into the equation, x equals y plus 2 means that x is going to be 3 plus 2, and that's 5. How do I check it? So I have x equal 5, I have y equals to 3, so 5 plus 3 is indeed equals 8. So my solution is going to be 5, 3. So this is considered exactly one solution. So this system is consistent and independent. Number 5. 2x plus y equals 4, x plus y equals 6. So this time, how do I substitute? So it looks like this equation is simpler than the first one. Why is it? Because both of my coefficients for x and y are 1. So if I rewrite this equation, as I subtract x to both sides, I can write it as y equals negative x plus 6. Then I have 1y, and then I can go ahead and plug it back into the first equation. So as normal, I'll put it in different color to tell you what I'm doing here. But first, I'm going to rewrite the first equation. So it's 2x, so that's what I'm given here, 2x, and then plus y. So what am I going to replace the y with? So as I have the second equation turn into y equals negative x plus 6. That's what I'm going to plug it in, negative x plus 6. So I replace the y that I see here as negative x plus 6. Then the whole equation equals to 6. So I have 2x plus x, negative x plus 6, which is x plus 6 equals 6. Now, what did I do wrong here? I have to erase. The given equation here is 4, not 6. Do you see that? The given equation to number 1 is 4. It should be 4. 4 here. So I apologize. It should be 4x plus 6 equals 4. So that means my x, as after I subtract 6 to both sides, my x is going to be negative 2. Then I plug it back into this one to find my y value. Y equals negative 2 plus 6, which is positive 8. Did I do it right? Let's plug in back into the first equation. 2 times negative 2 plus 8. So we have negative 4 plus 8, which is positive 4. So that matches up. That says my equation solution should be x equal to negative 2 and my y is positive 8. Negative 2, positive 8. So this is exactly one solution again. So this system is consistent, independent. Consistent, independent.